Hi, lazy developers here. My name is Melody Leonard, and in this tutorial series, we've been discussing about the blockchain technology, how to write smart contracts, and basically the solidity language, how we can utilize it, how we can write some code that actually run on the blockchain. So we agreed that we're actually going to look at the blockchain as a concept and what it actually is, so we'll better understand the smart contracts we are writing in our Remix IDE. For the now, though, we'll get to a point where we actually move to you know using whatever editor we want of our choice, do some local configurations and setup, and even connect any front-end application of our choice to the smart contracts we write and see what happens. So what is the blockchain? The blockchain is a decentralized system that kind of records information. And it does this in such a way that it makes it very hard or difficult to cheat the system. So it becomes almost impossible to hack. And this is achieved through a distributed ledger technology. And this distributed ledger technology uses an immutable, which is something that doesn't change, right? Cryptographic signature called hash. So when you hash something, you just can't change it, right? When something has been hashed, it just cannot change, right? And one thing about hashing is a one-way protocol. It means that when something is hashed, you can't reverse the process and get the original data. So it becomes hashed and it's just hashed. You can't reverse it. If you want to reverse, then you have to go for encryption, right? But when you hash something, it just stays that way. You can just not you can't go reversing the process. So here I say hashing is simply passing some data through a one-way formula that produces a result called hash. This follows a rule called proof of work consensus algorithm. And this proof of work consensus algorithm is simply a way for all these distributed computers to reach an agreement that a transaction has occurred. So these distributed computers all around the world have to reach an agreement that a transaction has occurred, or a transaction has not occurred, or a value is something, or a value is some other thing, right? So it's just a way of these computers reaching an agreement that, okay, this is actually true. I confirm that this is true, and this is true. Now, let's talk about the Ethereum blockchain. Ethereum is a distributed public blockchain network. And what it does is it kind of focuses on allowing you to run programming codes on its blockchain, right? It allows a station where you can actually write codes called smart contracts and deploy it to its blockchain. And these codes will run there, right? They can live there, they live in the blockchain. And what a smart contract is, a smart contract is basically a contract that is self-executable. And what this means is the normal way you do transactions, right? You can go ahead and say, okay, I want to exchange uh 2 million naira for $2,000 US dollars. And you see, you have to do this manually. But a smart contract, you can actually write a code that does it automatically, that is self-executable, right? That does this automatically. So you don't have to be there to watch the transaction occur, right? So you just write a code that does it automatically and gives you feedback whenever that happens and stuff like that. The Ethereum has its own native cryptocurrency though, and this is called Ether. And the Ether is actually and it equally has its dedicated programming language. which is solidity. So, you know, when you do transactions, your transaction, when you want to perform a transaction or when you want to push your code uh, to uh, to the Ethereum blockchain, or when you want to perform a transaction, right? You get to pay these things called gas fee, right? And this gas fee is paid in Ethereum, right? So you do pay this, right? Because of course there are computers verifying this information, notifying that okay, this actually is what it is, and this works. This amount is this, and that they have to verify that the transaction is correct, and something can be added to the blockchain and stuff like that. So you pay gas fee, and which of course these computers are rewarded in. So a gas is a computational effort required to execute a transaction on the Ethereum blockchain. Just like in your real world, right? If you have a car, you want to drive to somewhere, of course you have to fuel it, or add petrol or whatever, and that is of course your gas, and that allows you to propel or the car, or actually allows the car to run. Same with the blockchain. So you have to pay this amount called gas fee, and you see the amount of uh, the gas fee you pay depends on what you are actually doing. So when providing a gas fee, there is actually a limit to the gas you're willing to pay. So you can specify the limits to the gas you're willing to pay. You can specify that okay, I am not willing to pay more than this amount of gas for this transaction, right? And so that way, miners, or who's well, those verifying this transaction, will actually know that this is what you're willing to pay. So here it says a gas is a computational effort required to execute transactions on Ethereum blockchain. Gas fee are payments made by users to compensate for the computing energy required to process and validate transactions on the Ethereum blockchain. Now, remember we said our gas fees are paid in Ethereum, but there is a very, very tiny amount of Ether called GUI. So one GUI is equals, one 0.0.0.1. That's 1 to the ninth to the negative ninth power, and it's a very, very fraction amount, a small amount of ether. So instead of saying that you're actually paying this amount of Ethereum, you can actually say you are paying one GUI. And that brings us to the gas limits. So it is important to communicate to miners how much work needs to be done in order to process a transaction. This is done with the gas limits, which the blockchain wallet calculates automatically to ensure that transactions go through successfully. The limit also prevents overspending on mining fees. So you have to tell miners that okay, this amount I'm willing to pay, we just discussed, and I'm not willing to pay beyond this. Now, if the gas limit is set too low, a transaction can fail or get rejected, which would result in losing the gas paid for the transaction. So when doing this, you actually want to make sure that you set a good, reasonable amount of gas limits, right? So that your transaction doesn't fail. Because when your transaction fails, you lose your gas fee. It doesn't get returned to you. But if you put an excess amount of gas fee and it's being used, just like your diesel or petrol in your car, right? When you fill the tank and run a distance of about 1 mile, what happens? The leftover will still remain for you. So same way, if you send an over amount of gas fee and the transaction is successful, whatever you know whatever is left will be returned to you. So you get returns of whatever is left, right? And with that said, we'll have to write some more smart contracts. We have to look at a more uh, elaborate example on the solidity. We have to look at some other data types like address, struct, and so on. We have to look at how we can write or mint a token, and how that token can only we can actually, as the creator, be the one to actually mint that token. How we can transfer or send that token to a different address, different user, or address, and how we can perform all those transactions. Lazy developers here, stay tuned for it.